Scientific Beliefs and Discoveries in Elizabethan England by Amini and Elias. Introduction. In Elizabethan England, scientific beliefs and discoveries were heavily influenced by the prevailing cultural and religious norms of the time. While the period saw significant intellectual and scientific advancements, there was also a mixture of curiosity, skepticism, and adherence to traditional beliefs. The scientific landscape had to navigate the delicate balance between pushing the boundaries of knowledge and accommodating religious and cultural expectations. Galileo Galilei. Galileo Galilei, 1564–1642, was an Italian physicist, mathematician, astronomer, and philosopher who made significant contributions to the scientific understanding of the world. He is widely regarded as one of the key figures in the scientific revolution. Galileo's discoveries and achievements include telescope observations. Galileo is famously known for his observations using the telescope. He improved upon the existing designs and made significant discoveries. He observed the moon's surface and its mountains and craters, which challenged the belief in the moon's perfect and unblemished nature. Galileo also discovered the four largest moons of Jupiter, now known as the Galilean moons, and their orbits, providing evidence for the heliocentric model of the solar system. Heliocentrism and the Copernican model. Galileo's observations of the moons of Jupiter and his study of planetary motion provided support for the heliocentric model proposed by Nicolaus Copernicus. This model proposed that the Earth and other planets revolve around the Sun, contrary to the prevailing geocentric belief. Galileo's support for this model and his defense of it in his book Dialogue Concerning the Two Chief World Systems brought him into conflict with the Catholic Church. Laws of motion. Galileo conducted experiments with inclined planes and rolling balls, leading him to formulate the laws of motion. His work challenged the Aristotelian view that heavier objects fell faster than lighter ones. Galileo's experiments and observations laid the foundation for Isaac Newton's laws of motion. Pendulum motion. Galileo studied the motion of pendulums and discovered that the time it takes for a pendulum to swing back and forth, its period, is constant regardless of the amplitude of its swing. This insight had implications for the development of accurate timekeeping devices such as pendulum clocks. Laws of falling bodies. Galileo conducted experiments to study the motion of falling bodies and formulated the laws of falling bodies. He demonstrated that objects of different masses fall at the same rate in a vacuum, discounting the effects of air resistance. This challenged the prevailing belief that heavier objects fall faster. Galileo's discoveries and scientific contributions were groundbreaking and had a profound impact on the scientific community. However, his work often brought him into conflict with the Catholic Church and the prevailing orthodoxy of the time, leading to his persecution and house arrest. Nonetheless, his observations, experiments, and defense of the heliocentric model laid the groundwork for the scientific revolution and the development of modern physics and astronomy. That's all, and thanks for listening.